We're given r prime of t and also the value of r at t equal 1. So we know that r is the antiderivative of r prime. It is the vector function that we take the derivative of to get r prime. And so we need to take the antiderivative of r prime to get r. We do that component by component. Find the antiderivative of 5t to the fourth times I plus the antiderivative of 7t to the sixth times j plus the antiderivative of t to the 1/4 power times k. Okay. Our first antiderivative of 5t to the fourth is 5 times t to the fifth over 5, so the 5's cancel, we get t to the fifth, plus a constant of integration, which we'll call c1 because we're going to have 3 of them. Then the antiderivative of 7t to the sixth is 7t to the seventh over 7. The 7's cancel, leaving us with t to the 7, t to the 7th power, plus our second constant of integration, all together times j. And finally we get t to the 1/4 plus 4/4, that's t to the 5/4, divided by 5/4, so that's the same thing as multiplied by 4/5, and then plus our third constant of integration, c3. Now we need to solve for c1, c2, and c3, and that's where our second piece of information that r of 1 equals I plus j comes in. Okay. So what we just integrated to get was r of t, and r of 1 we're told is supposed to equal 1 times I, I'm being explicit about the coefficients here, plus 1 times j, plus apparently 0 times k, since there is no k in our value here. Okay, so these two things should be equal when I plug in 1 for t on the over here, and so 1 to the fifth is 1 plus c1 is what we get over here, and then 1 to the 7th, which is 1, plus c2 is our second component, and 4/5 times 1 to the 5/4, that's 4/5 times 1. 1 to any power is 1. Plus c cubed is our coefficient when we plug in 1 for t in our antiderivative. Since these are the same, they're both r of 1, then our components have to be equal. The 1 we get over here has to equal the 1 plus c1 that we have in our antiderivative, and the 1 we get as a coefficient of j over on the right side there has to equal the 1 plus c sub 2, and finally the 4/5 plus c3 has to equal 0 for these to be equal to one another, and that gives us 3 equations to solve. We find out that c1 is 0, c2 is 0, but c3 is negative 4/5. So now we can rewrite our result for r of t, replacing the constants of integration with their actual values. So we're going to wind up with t to the 5th plus 0, which is t to the 5th as our first component, t to the 7th plus 0, which is t to the 7th as our second component, and here's our only non-zero constant of integration, 4/5 t to the 5/4 plus a negative 4/5, which is minus 4/5. And there's our final result without any constants of integration left in it. We've solved for all of them. And I'm not going to rewrite it up here, I'm just going to indicate that our final result is right here. We are done. We have found r of t.